Okay, so the second part of your worksheet is on percent calculations, percent compositions. And again, that's our two-step process. Step number one, we've got to calculate the molar mass, and then we've got to do our ratios. All right, so first question, percent phosphorus and percent oxygen in P2O5. Diphosphorus pentoxide is that particular compound. So step number one, first step we have to do is figure out what 1 mole of phosphorus pentoxide weighs. So phosphorus is how many grams per mole?
Where is it? Where is phosphorus?
There, number 15. How many grams per mole? 30 what? 30, let's round to 31.
31.
31 grams per mole. We have 2 atoms, so we've got to multiply that by 2. So that's 62 grams per mole. Our oxygen is 16 grams per mole. We have 5 of those. And 5 times 16 is 80, yes? Grams per mole. Add those together. And what is 1 mole of that weigh?
142.
142 grams per mole. All right, so that's step A. Step B, we then do our ratios. So our first ratio is our total phosphorus was 62. 62 grams per mole. The entire compound weighs 142 grams per mole. And multiply that times 100%. What does that work out to be?
Can we work that out?
43.7% of that compound is phosphorus. The oxygen component, what was our oxygen total? 80. 80 grams per mole. Divide by that 140 grams per mole again, times 100% equals 56.3%. Now, when I add these two together, the 43.7, the 56.3,
Should make 100.
Kareem, spot on, dude. Should make up 100%. That's how you can check your work on these. If they don't equal 100%, you've screwed up somewhere, exactly. Wow, there are 5 of these? Goodness gracious. All right, that's our pattern. Next one, percent carbon, percent oxygen in CO2. All right, 2% carbon, percent oxygen in CO2. CO2, we've said a couple of times, is 44 grams per mole. So we can do this real quick, but we need to know what the constituents are, don't we? The carbon is 12. The oxygen is 32. So our ratios are 12 over 44 times 100, and then 32 over 44 times 100. And who's crunched those numbers already?
Figure this out really quick.
JM, would you have 20? 27.3%. And we could do the math, subtract that by 100, but we're not gonna.
These 2.7.
So 2.7%, they do add up to 100. All right, everyone take a moment. If you did not get that on Thursday, write those down, You've got to be able to do these. All right, number 3, we've got 3 components now. We have 3 elements making up sulfuric acid. Dude, relax, you're fine. I see all your work right there. Okay, number 3, percent hydrogen, percent sulfur, and percent oxygen in H2SO4, sulfuric acid in H2SO4. Hydrogen is 2. Sulfur, let's go to the table. Sulfur, anyone, tell me what sulfur weighs? A mole? 32. 32, we've got 4 oxygen. 4 times 16 is 64. All right, so in total, 2, 34, and 64 is 98. So 98 grams per mole. Our ratios are 2/98 for the hydrogen, 32/98 for the sulfur, and then lastly 64/98 for the oxygen. Times 100%. 100%. Who's crunched those? 0.02%. Did we multiply that times 100?
Oh, no.
Alright, so that's 2.04.
Yeah. 2.04. Looks a little better. Next one.
32.65.
Okay, so there's not much hydrogen by weight in that. 32.65%. And then lastly, oxygen is often the heaviest component. 65.3%. Thank you, Trent. All right, and with some rounding, those are going to add up to 100%, so we're good there. All right, take a moment, make sure you've got those ratios copied and calculated. You want writing? Trent, you got it? All right, number 4. Glucose.
Sugar.
Yeah. Any of you going into a medical field, glucose is your friend. You want to know all about it.
Yeah, I'm an EMT.
This is your friend. Or let's say you go in the plant field.
Say you're an EMT or EMT.
All right, so percent H, percent carbon, percent oxygen, and our glucose is C6H12O6. Here's our math, sort of. 6 times 12 for the carbon.
72.
72. 12 times 1 for our hydrogen, which is 12, and then 6 times 16 times
96.
16, 96. When I add all three of those up, how much does a mole of glucose weigh? 180? 180. 180 grams per mole. All right, by now you probably already started setting up your ratios. Our carbon is 72 over 180. Our hydrogen, 12 over 180. And don't forget times 100%. And then our oxygen, once again, the heavyweight, 96 over 180. How we doing? You guys are rolling along here. Just a second. Just a second. One more problem, and then we will close with a little dirty jobs. We'll have a few minutes left. Little dirty jobs. All right, carbon percentage is?
6.66%.
I got 40%.
I'm liking her number a whole lot better.
I got 40%, sir.
Is it 40% even?
Yes.
Yep. All right, that looks more like, that's not
Yeah.
quite half.
I was looking at hydrogen.
That's all right. Oh, so hydrogen, 12 divided by 180 is
6.66%.
6.67%.
I was looking at that one.
Instead, yeah, then that's the way I wrote it. This would have been more correct. And then finally, the heavyweight is what, about 53%? 53.34%. And then we can look at that and see that
Once
that is
again,
100%.
oxygen is the heavyweight.
The heavyweight champion of glucose. All right, we're just going to make sure everyone is, because I'm always in Isabel's way. Okay, this is all second nature now. All right, finally, nitric acid is the last